Hello everyone, this is Laminda once again, and I will be doing the motorized pinwheel project. Starting off with hardware, we have the breadboard, we have the Arduino Uno, we have a 9-volt battery that powers the whole system. We have a pinwheel motor, it's an electric motor. That is our output. That's the whole purpose of this project, is to basically have a switch that controls this motor. And let me just really quickly do the simulation. I think that would be helpful. So the whole purpose of this project, like I said, is to press the switch and have the motor run up to a certain amount of RPMs. So if I hit the switch, the motor goes up to 7,301 RPM. And then if I let go, the motor stops. Push it again, the motor turns on. And so it's really like an on or off sort of system where there's no sort of modulation or like modularity in terms of like the control that you have over the motor itself. So it's really just this switch is just on, goes to 7,301 RPM, and then you let go, it just goes off. So like I said, there's a 9-volt battery that powers the whole system. There is a MOSFET transistor, which is new. I'll go over that here in a little bit. And then we of course have a 10 kilo ohm resistor, and we have a diode. Those are, and the switch itself. Those are the primary parts of the hardware. Of course, we have wiring. We have the red wire, once again, going from the 5-volt to the power rail. We have the black wire going from the ground to the ground rail. We have the switch itself is connected to pin number 2. We have the MOSFET transistor that's connected to the pin number 9. And the MOSFET transistor is actually wired to the motor. So it's wired from the Arduino Uno from the number 9 pin, and then the MOSFET transistor is actually wired from here to the motor itself. And the reason for that is because the MOSFET transistor actually can take in low voltage from the breadboard, or sorry, from the Arduino Uno or the breadboard, and actually convert it to high voltage, high power output, so that you can actually have that can actually be outputted to the motor. Here on the right is my code for the system. These here are constants that I didn't name it, but this was like the recommending naming sort of nomenclature that I used, or there was the default names that the project asked for. So switch pin here is the actual switch itself, and that's as you can see is in the is equal to the 2 input pin, or sorry, the 2 pin, and then the motor pin is connected to the number 9 pin here, and it may not seem like it, but once again it's connected to the MOSFET transistor, and the MOSFET transistor then outputs the power into the motor. So it's basically controlling the low voltage that's being outputted by the Arduino Uno and converting it into high voltage. Just to reiterate, and then the switch state, setting that equal to 0 is sort of like a neutral command. It's basically saying that the switch state is off and ready to accept a command. The void setup here, this code runs only once. Again, it's the I mentioned this earlier in one of my previous projects, but this right here is the swirly brackets are the ones that denote where the code is. And so it starts here, ends here, and same for the void loop, starts here and ends here. Okay, so the pin mode here we're sort of defining the motor pin to be the output. And that makes sense because the motor is the output. If you think of the system like a function, the switch pin then should be the input because the switch pin is is the one that's actually being manipulated. So you press the switch pin, that's the input, and the output should be the motor RPMs, or the motor spinning. Then once that's once that code has gone over, then you go through the void loop, and here the switch state is set to digital read, and we're digitally reading the switch pin. And what this does is the digital read function basically checks if there's voltage in the switch pin. In this case, it's pin number 2. And this will determine whether the system is on or off, whether there's voltage going into the switch pin or not. And basically, if you follow the code, then that means that if the switch state is high, then it's on. Then the motor should be on. However, when the motor pin is low, then the system is off, then the motor is off. So just to reiterate, if the switch state is high, then the motor pin is also high, which means that it's on. However, if this argument is not met, so if the switch state is not high, then you have this else. Again, it's like an if-then statement, right? So if this, then you do this. However, if this is not the case, then you do this. So if the switch state is low, in other words, then the motor pin should be low or off. And that is the assembling the Pinwheel project. Any feedback would be appreciated. Thank you.